we need to find the product of all solutions of the equation e to the power 5 log x whole square plus 3 is equal to x power 8 for x is positive. Let us consider log x to the base e is equal to 8 is equal to t. So that the given equation we can write e to the power 5t square plus 3 is equal to x to the power of 8. And we know the conversion of logarithmic form to exponential form, that is a power m is equal to n. We can write log n to the base a is equal to m. So let us consider here m is equal to 5t square plus 3 and x power 8 is equal to like n and a is nothing but e. So that we can write in logarithmic form as log x power 8 is equal to the base e 5t square plus 3. Also we had the properties log a to the power of m to the base is equal to m times of log a to the base x. So here we can write 8 times of log x to the base e is equal to 5t square plus 3. Since log x to the base is equal to t, so we can write 5t square plus 3, that is 8t is equal to 5t square plus 3, or we can write 5t square minus 8t plus 3 is equal to 0. And now factorizing 5t square, and here 5 3s are 15 and this difference is 8, so we can write minus 5t minus 3t plus 3 is equal to 0. 5t taken common, so t minus 1, minus 1 taken common, minus 3 is taken common, t minus 1 is equal to 0. So t minus 1 into 5t minus 3 is equal to 0. So t minus 1 is equal to 0, 5t minus 3 is equal to 0. So t is equal to 1, t is equal to 3 by 5. When t is equal to 1, that is log x to the base e is equal to t, so which implies x is equal to e to the power, log x to the base is equal to 1. Log x to the base is equal to 1, so x is equal to e to the power 1, that is e. And when t is equal to 3 by 5, log x to the base is equal to 3 by 5, so we can write x is equal to e to the power 3 by 5. And now these are the two solutions. So product of the solutions we can write product of solutions is equal to e into e to the power 3 by 5, that is e to the power 1 plus 3 by 5, which is equal to e to the power 8 by 5. So e power 8 by 5, which is option A, is the answer. Given set A is equal to 1, 2, 3 and so on up to 10, and B is equal to m upon n, where m and n belongs to the set A, and also m is smaller than n, and GCD of m comma n is 1. Then we need to find the number of elements in the set B. Let us find the elements in the set B with the conditions m upon n, where m and n belongs to the set A, and also GCD of m and n is 1, means there is no common factor other than 1. So if we start with 1, so I can write 1 upon 2, 1 upon 3, 1 upon 4, 1 upon 5, and so on up to 1 upon 10. So here total 9 elements are there. And if I start with 2, 2 upon 3, 2 upon 4 we cannot take, 2 upon 5, 2 upon 6 we cannot take, 2 upon 7, 2 upon 9. So only 4 are there. And starting with the 3, 3 upon 4 I can consider, 3 upon 4, 3 upon 5, 3 upon 6 is not possible, 3 upon 7, and 3 upon 8, 3 upon 10. So again here 5 are there. And now if I start with 4, 4 upon 5, 4 upon 6 we cannot take, 4 upon 7, 4 upon 8 we cannot take, 4 upon 9, 4 upon 10 also we cannot take. So 3 are there. And next if I start with 5, 5 upon 6, 5 upon 7, 5 upon 8, 5 upon 9, 5 upon 10 we cannot take. So 4. So if I start with the 6, 6 upon 7, 6 upon 8 we cannot take, 6 upon 9 also we cannot take, 6 upon 10 also we cannot consider. So only 1. And if I start with the 7, 7 upon 8, and 7 upon 9, and 7 upon 10. So here 3 elements are there. And if I start with 8, 8 upon 9, 8 upon 10 we cannot consider. So only 1 element. And if I go with 9, so 9 upon 10, it's only 1 element. So 10 upon 10 we cannot consider because m should be less than n. So here total number is 9 plus 4 13, 13 plus 5 18, 18 plus 3 21, 21 plus 4 25, 26, 26 plus 3 29, 29 plus 2 31. So we can say that the number of elements in set B is 31. So we can go with an option B. Z1, Z2 and Z3 be 3 complex numbers on the circle mod Z is equal to 1. It's a unit circle. So let us consider it's a unit circle with the center is origin. And since it is given argument of Z1 is minus pi by 4, so we can have on the fourth quadrant with the negative pi by 4, that is Z1, and argument of Z2 is 0, so the angle is 0, so we can consider on x-axis. So Z2, so clearly it is a point 1 comma 0, and with Z3 again with pi by 4, argument of Z3 is pi by 4, so that we can write Z1 is equal to the mod of Z1. And we know that since all the 3 points lie on the circle mod Z is equal to 1, so we can write mod Z1 and mod Z2 and mod Z3 is equal to 1. So we can write mod Z1 cos of minus pi by 4, because we know that mod Z1 into cos theta plus I sin theta is a formula. So we can write 1 into cos of minus pi by 4 plus I sin of minus pi by 4. Cos of minus pi by 4 is 1 by root 2 plus I sin of minus pi by 4 is minus 1 by root 2. So we can write 1 minus I divided by root 2. Similarly, Z2 is equal to mod Z2 is 1 and again cos 0 plus I sin 0. Or simply we can write 1 plus I, 1 plus 0 I, that is cos 0 is 0, sorry cos 0 is 1, sin 0 is 0. So we can write 1. And coming to Z3, mod Z3 which is 1, and cos argument is pi by 4, so we can write cos pi by 4 plus I sin pi by 4, which is equal to 1 by root 2 plus I by root 2, that is 1 plus I divided by root 2, which is Z3. Now let's consider Z1 Z2 bar, which is equal to Z1 is 1 minus I divided by root 2, and Z2 is 1, it's a real number, so its conjugate is also the same number, so we can write only 1, which is equal to 1 minus I divided by root 2, and Z2 Z3 bar is equal to Z2 is 1 and Z3 is equal to 1 plus I by root 2, its conjugate will be taken as 1 minus I divided by root 2, so we can write 1 minus I divided by root 2. Z3 Z1 bar, that is 1, so 1 plus I whole square divided by 2, 1 plus I whole square divided by 2, which is equal to 1 minus 1 plus 2I divided by 2, which is equal to I. So let us substitute in the question. If Z1 Z2 bar plus Z2 Z3 bar plus Z3 Z1 bar is equal to whole square is equal to alpha plus beta root 2, so let us substitute there. So we can get 1 minus I divided by root 2 plus 1 minus I divided by root 2 plus I, the mod whole square. Let us simplify this. So we can write root 2 is common in the denominator. 1 minus I plus 1 minus I, that is 2 minus 2I, and again here root 2I whole square. So which is equal to, or we can take root 2 common in the numerator. So we can write a root 2 minus root 2I plus I divided by root 2 whole square. So that the numerator and denominator root 2 get cancelled. So which is root 2 plus 1 I times of 1 minus root 2 the mod whole square. So modulus is nothing but root of a square plus b square. So root 2 whole square plus 1 minus root 2 whole square the under root the whole square. So we can remove the root and we can write root 2 whole square is 2 and a minus b whole square we can write a square plus b square minus 2 root 2. So 2 plus 2 4 plus 1 5 minus 2 root 2. So we got it 5 minus 2 root 2, which can be compared with alpha plus beta root 2. So when it is compared with alpha plus beta root 2, so we have alpha is equal to 5, beta is equal to minus 2. So that we can get alpha square plus beta square is equal to 5 square plus minus 2 whole square, that is 25 plus 4, that is 29. So we can say the answer is 29, which is option B. R is equal to 0 to 5, 11C 2R plus 1 upon 2R plus 2 is equal to M upon N, and GCD of M and N is 1, then we need to find the value of M minus N. So if you expand it, you will be getting 11C 2 times 0 plus 1, that is 1, 11C 1 divided by 2 into 0 plus 2, that is 2 plus, and when R is equal to 1, so we can write 11C 2 ones are 2 plus 1, 3 divided by 2 times of 1, that is 2 plus 2, that is 4, and next 11C when R is equal to 2, 2 to the 4 plus 1 5 divided by 2 to the 4 plus 2 6 and so on. 11C 2 5 is a 10 plus 1 11 divided by when R is equal to 5, and here 2 5 is a 10 plus 2 12, and which is given as M upon N. So to get this one, let us consider 1 plus x whole to the power 11, which is equal to 11c0 plus 11c1 x power 1, 11c2 x to the power 2, and so on, 11c11 x to the power 11. So this can also be written c0 plus c1x, c2x square, and so on, c11 x to the power 11, where c0, c1, c2 and c11 are the binomial coefficients. So now integrating on both the sides, with the limits 0 to 1. So we get integral 0 to 1, 1 plus x whole power 11 is equal to integral 0 to 1, c0 plus c1x plus c2x square, and so on up to c11 x to the power 11 dx. So we can write 1 plus x whole to the power 12 divided by 12 over the limits 0 to 1, which is equal to c0 x plus c1 integration of x is x square by 2 plus c2 x power 3 divided by 3, and so on up to c11 x to the power 12 divided by 12. So over the limits 0 to 1. Now applying the limits here, 1 plus 1, that is 2 power 12 divided by 2, minus 1 plus 0, that is 1 power 12 is 1 divided by 12, which is equal to c0 into 1 plus c1 into 1 by 2, and here we can write c2, 1 cube is 1 upon 3, plus and so on, c11, 1 power 12 is 1 divided by 12. So we can consider 2 to the power 12 minus 1 upon, sorry, here it is 12, so 12, which is equal to c0 by 1 plus c1 by 2 plus c2 by 3, and so on up to c11 divided by 12. Let us consider this an equation B. Integrate again A, integrating on both the sides from the limits minus 1 to 0. So we'll get integral minus 1 to 0, 1 plus x whole power 11 is equal to integral minus 1 to 0, c0 plus c1x plus c2x square, and so on, c11 x power 11 dx. So we get 1 plus x whole to the power 12 divided by 12 over the limits minus 1 to 0, which is equal to c0 x plus c1 x square by 2 plus c2 x to the power of 3 divided by 3, and so on, c11 x to the power 12 divided by 12 over the limits minus 1 to 0. So that we can write here the upper limit is 0, so 1 plus 0, that is 1 power 12 1 by 12 minus of, and again here the lower limit 1 minus 1, so 1 minus 1 is 0, 0 upon 12 is 0, which is equal to, and here the upper limit will be 0 minus, and the lower limit we can write c0 into minus 1, that is minus c0, and again plus c1 into minus 1 whole square will become plus 1, that is c1 by 2, and minus 1 whole cube will become minus, so minus c2 divided by 3, and again plus and so on up to minus 1 whole to the power 12 is 12, 1, so we'll get c11 plus c11 divided by 12. So which can be written as 1 by 12 is equal to c0 minus c1 by 2 plus c2 by 3 minus and so on up to minus c11 divided by 12. So which can be considered the equation as a C. Equation from B. So we get c0 minus c0 gets cancelled. or let me write here 2 power 12 minus 1 divided by 12 minus 1 by 12 is equal to C naught minus C naught plus C1 by 2 minus of minus plus C1 by 2 plus C2 by 3 minus C2 by 3 and so on. C11 by 12 minus of minus plus C11 by 12. So we can write 2 to the power 12 minus 1 2 to the power minus 2 divided by 12, which is equal to 2 times of C1 by 2 plus C3 by 4 and so on, C11 divided by 12. So this can also be written as, by taking 2 common here, 2 power 11 minus 1 divided by 12 is equal to 2 times of, we know that C1 by 2 plus C3 by 4 and so on is nothing but m by n. So here I can write m upon n, and here we can cancel 2 and 2. So m is equal to, we can compare 2 power 11 minus 1 and n is equal to 12. So therefore m minus n is equal to 2 power 11 minus 1 minus 12, that is 2 power 11 minus 13. So 2 power 11 value is 2048 minus 13. So we can get 2035. So 2035 is the answer. From all the English alphabets, 5 letters are chosen and are arranged in alphabetical order. The total number of ways in which the middle letter is M. So we know that there are 26 alphabets, A, B, C and so on, M, N and so on up to Z. So M is the 13th position, 13th letter we can say. So before M there are 12 letters are, and after M there will be 13 letters. So total 26 letters are there. We need to arrange 5 letters in such a way that M is always placed in the middle and these letters should be in alphabetical order. So before M, these 2 letters should be in alphabetical order, which can be selected from the 12 letters. So here we can say out of 12, we have to select 2 letters. We are not supposed to arrange it because we need alphabetical order. Like an example, AB, or we can say AC, or we can say BC. So this is how we can select in 12C2 ways. Similarly, after M, since there are 13 letters, out of 13 letters, we have to select 2 letters in alphabetical order. We are not supposed to arrange. So 12C2 into 13C2, and M is a fixed way. So we can say this is only one way. So finally we can say that the required number of ways is equal to 12C2 into 13C2. 12C2 into 1 into 13C2, that is NCR formula, n factorial divided by n minus r factorial into r factorial. So here 12C2 we can write it as 12 factorial divided by 12 minus 2, that is 10 factorial into 2 factorial, into 13C2 we can write 13 factorial divided by 13 minus 2, that is 11 factorial, into 2 factorial. So we can simplify 12 into 11 into 10 factorial divided by 10 factorial into 2 factorial, we can write 2 into 1, and here 13 factorial we can write 13 into 12 into 11 factorial divided by 11 factorial into 2 into 1, so that we may cancel here 10 factorial and here 11 factorial and here 2 6 times and here 2 6 times. So we can write here 6 11s are 66 into 13 into 6. So 66 into 13 into 6, after calculation you will get 5148. 5148 is the answer, which is our option 4. 5148 ways we can arrange. A1, A2, A3 be a geometric progression of increasing positive terms, and A1, A5 is equal to 28 and A2 plus A4 is 29. Then we need to find A6. Let us consider A1 is equal to A, first term is A, and R is the common ratio. So then we can write A2 is equal to AR, A3 is equal to AR square, A4 is equal to AR power 3, and A5 is equal to AR power 4. And it's given A1 A5 is equal to 28. So we can write A into AR power 4 is equal to 28. So this can also be written AR into AR power 3 is equal to 28. Similarly, A2 plus A4 is equal to 29, that is AR plus AR power 3 is equal to 29. So for some time let us consider AR is equal to P and AR cube is equal to Q. So which implies P into Q is equal to 28 and P plus Q is equal to 29. So by our assumption we can consider P is equal to 28, Q is equal to 1, or P is equal to 1, Q is equal to 28. And also from here the ratio P upon Q, so or Q upon P, let's consider Q upon P, which is equal to AR power 3 divided by AR, which is equal to R square. So Q upon P is equal to R square. So here Q upon P value will give 1 upon 28, which is equal to R square. And here in this case Q upon P is equal to 28 divided by 1 is equal to R square. Now let us consider A6, which is equal to AR power 5, that is AR into R to the power 4, that is AR into R square whole square. So when P is equal to AR, that is 28, so we can write when AR is equal to 28, then 28 into, then R square value is 1 upon 28, so 1 upon 28 into 1 upon 28, so you're getting 1 upon 28. And when AR is equal to 1, that is P is equal to 1, so we have R square is equal to 28, so we can write A6 is equal to AR into R square whole square, that is 1 into 28 whole square. 28 whole square is 784. So 784 will be the answer for this question because it's an increasing positive terms. So we can go with an option A. Given that sum of the terms r is equal to 1 to n tr, which is given as 2n minus 1 into 2n plus 1 into 2n plus 3 into 2n plus 5 upon 64. Then we need to find the limit n tends to infinity. This summation 1 r is equal to 1 to n 1 upon tr. So here we have Sn is equal to 2n minus 1, 2n plus 1, 2n plus 3 into 2n plus 5 upon 64. Let us find the term. For this we need to find Sn minus 1. So we can add 2 times of n minus 1 minus 1, 2 times of n minus 1 plus 1, 2 times of n minus 1 plus 3, 2 times of n minus 1 plus 5 divided by 64. So which is equal to, and here we can write 2 times of 2n minus 2 minus 1, that is 2n minus 3, and here 2n minus 2 plus 1 is minus 1, and here 2n minus 2 plus 3, that is 2n plus 1, and here we can write 2n plus 3 divided by 64. So that we have Sn minus 1, which is equal to Tn. We can take common 2n minus 1 and 2n plus 3 and 2n plus 1. These are the terms we can take common, divided by 64, and the remaining terms we can write 2n plus 5 minus of 2n minus 3, and simplifying we can get, and here we can write 2n plus 5 minus 2n plus 3, that is 8. So 8 upon 64 into 2n minus 1, 2n plus 1 and 2n plus 3. 8 times. So we got 2n minus 1, 2n plus 1, 2n plus 3 divided by 8. Then 1 upon Tn, which is equal to 8 upon 2n minus 1, 2n plus 1 and 2n plus 3. Let's take 1 upon 2n minus 1 common. And here the difference between 2n plus 1 and 2n plus 3 is 2. So let us write 4 as 8 as 4 into 2. So 4 here, and here I can write 1 upon 2n plus 1 minus 2n plus 3. So that the difference of these two numbers is 2 and the denominator is 2n plus 1 into 2n plus 3. So we can write 4 upon 2n minus 1 into 2n plus 1 minus 4 upon 2n minus 1 into 2n plus 3. That is 4 taken common. Or here the difference between 2n minus 1 and 2n plus 1 is 2. So I can take only 2 common. So if 2 is taken common, so you can add 1 upon 2n plus 1, 2n minus 1 minus of 2n plus 1. And again here, the difference between 2n minus 1 and 2n plus 3 is 4. So you can just write, you can write 1 upon 2n minus 1 minus 2n plus 3. Now applying summation. So we get summation r is equal to 1 to n. 1 upon tn is equal to, so we can write 2 times of, when r is equal to 1, so here we can write 2 ones are 2, 2 minus 1, 1 upon 1 minus 1 upon 2 ones are 2 plus 1, 3, and again plus, if r is equal to 2, so r is equal to 2, we'll get 1 upon 2 2s are 4 minus 1, 3, minus 1 upon 2 to the 4 plus 1, 5, and so on. And again here minus of the second term, 1 upon, if we take n is equal to 1, so 2 ones are 2 minus 1 is 1, minus 1 upon 2 ones are 2 plus 3 5 plus 1 upon 2 2s are 4 minus 1 3 minus 1 upon 2 2s are 4 plus 3 7 and again plus 1 upon 2 3s are 6 minus 1 5 and minus 1 upon 2 3s are 6 plus 3 9 and so on. So here we can see that this minus 3 plus 1 by 3 gets cancelled and again minus 5 will be getting cancelled with another term. So you'll be getting only 2 times of 1 and minus here 1 upon 5 will be getting cancelled with here and 1 upon 7 also will be cancelled for the other terms and 1 upon 9. So we'll be left with only 1 as n tends to infinity. Here we can write as limit n tends to infinity summation 1 upon tn where r is equal to 1 to n. So we can expand it and we can say that the rest of the terms will be cancelled. So the remaining terms are only 1 minus 1 plus 1 by 3. So which is equal to 2 minus 1 minus 1 by 3. That is 1 minus 1 by 3. 3 ones are 3 minus 1, that is 2 upon 3. So as n tends to infinity, the summation can be taken as only these three terms. So 2 minus 1 minus 1 by 3. So we'll be getting the answer 2 by 3, which is our option C. Let the triangle PQR be the image of the triangle with the vertices. Let us consider ABC. A is 1 comma 3, B is 3 comma 1 and C is the point 2 comma 4. And in the line, with respect to the line, x plus 2y is equal to 2. If the centroid of the triangle, is given, PQR is alpha comma beta. So let us consider alpha comma beta is the centroid. Then 15 times of alpha minus beta is, means we need to find the centroid of the triangle ABC. Let us consider G dash. Centroid of triangle ABC. We know the formula. Centroid of triangle is x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 by 3. So we can write 1 plus 3 plus 2 divided by 3 and the y coordinates 3 plus 1 plus 4 divided by 3, which is equal to 3 plus 3 6 upon 3 comma 3 plus 1 4 upon 4 plus 4 is 8 upon 3. So we can write 2 comma 8 upon 3. So 2 comma 8 by 3 is the centroid, and let us consider G is the centroid of a PQR triangle alpha comma beta. Since this 2 comma 8 by 3, we need to find the image of, now we need to find image of point 2 comma 8 by 3 with respect to the line x plus 2y minus 2 is equal to 0. So we know the concept. If h comma k is image of the point x comma y with respect to the line ax plus by plus c is equal to 0, then we have the relation h minus x or x1 y1. Let us consider h minus x1 upon a is equal to k minus y1 upon b is equal to minus 2 times of ax1 plus by1 plus c upon a square plus b square. So let us apply this formula here, the concept. So we can write, so here h comma k is alpha comma beta, so we can write alpha minus 2 divided by the coefficient of x is 1, which is equal to beta minus y1 is 8 by 3 divided by the coefficient of y is 2, which is equal to minus 2 times of ax1. So here a is equal to 1 So x1 is 2. So 1 into 2 and plus b, that is 2 times of 8 by 3 and minus 2 divided by a square plus b square, that is 1 square plus 2 square. That is alpha minus 2 upon 1 is equal to beta minus, that is 3 beta minus 8 upon 6 is equal to, and here the simplification we can say minus 2 into 1 2s are 2, and here it is plus 16 by 3 and again minus 2 divided by 5. So here 2 gets cancelled and here minus 32 divided by 15. So we can get minus 32 divided by 15. So alpha is equal to 2 minus 32 by 15, that is 15 2s are 30 minus 32, that is minus 2 divided by 15. Similarly 3 beta minus 8 is equal to minus 32 by 15 into 6. So here 3 2 times, 3 5 times, and again plus 8 we can write 3 beta is equal to minus 64 divided by 5 plus 8. Let me write here 3 beta is equal to minus 64 plus 5 8s are 40 divided by 5, which is equal to minus 24 divided by 5, or 3 beta is equal to minus 24 by 5 into 1 by 3. So beta is equal to minus 8 by 5. So alpha value is minus 2 by 15. So we can write alpha is equal to minus 2 by 15 and beta is equal to minus 8 by 5, and we need to find the 15 times alpha minus beta. So this minus 8 by 5 we can also write by multiplying and dividing with 3. So beta is equal to minus 24 by 15. So alpha minus beta is equal to minus 2 by 15 plus 24 by 15, that is 22 by 15. So 15 times of alpha minus beta is equal to 22. So we can go with an answer 22. Given a circle of radius 2 lies in the second quadrant. So let us consider this a circle C with radius 2 units. So we can say that this point is here minus 2 comma 0. So we can say the center of the circle C is minus 2 comma plus 2. Let us consider this is C1, and it touches both the coordinate axis, and let R be the radius of another circle. Let R be the radius of another circle. Let us consider C2 is the center for the second circle, and the center is given 2 comma 5. Say this is C1 and C2 is 2 comma 5, and intersect the circle at the exactly at 2 points, say P and Q. If the set of all possible values of R is in the interval alpha comma beta, then what is 3 times beta minus 2 times alpha? This question is totally based on the condition of two circles intersecting. So we know that two circles with the center C1 and C2 and radius R1 and R2 intersecting, then we can take the condition C1 C2 is lies between mod of R1 minus R2 and here R1 plus R2. So here we can say the distance between the two centers C1 C2 is equal to under root of 2 minus of minus 2 whole square plus 5 minus 2 whole square. So we can get 2 minus of minus 2 is 4 square, 5 minus 2 is 3 square. So we have 4 square plus 3 square, 16 plus 9, 25, which is 5 units. So distance between the two centers is 5 units. So 5 lies between. So here we can say R plus 2 and here R minus 2. So we can simplify. 5 is less than R1, R plus 2. So R plus 2 is greater than 5. So r is greater than 5 minus 2 is 3, and here we can say r minus 2 is less than 5, r is less than 7. So therefore the range of r is 3 and 7. Since it is given alpha comma beta, so alpha is equal to 3 and beta is equal to 7. So we need to find 3 times beta minus 2 times alpha, which is equal to 3 times of 7 minus 2 times of 3, 21 minus 6, which is equal to 15. So we can go with an option C. 15 is the answer. Given the foci of a hyperbola are 1 comma 14 and 1 comma minus 12, and if it passes through the point 1 comma 6, then the length of the lattice rectum. Since the hyperbola foci is given 1 comma 14 and 1 comma minus 12, so we can say the axis is x is equal to 1. X is equal to 1 is the axis of the hyperbola, and 1 comma 14. So the point 1 comma 6 whose x coordinate is 1. So definitely the point will be here 1 comma 6 point. It's a vertex, we can say. And we know that SP minus S dash P, which is equal to 2A. So we can write the distance between the S and P. So 14 and 6. So we can write here 8 units. So here 8 units SP. And S dash P, we can write here 12 units and here 6 units. So 12 plus 6 is 18. So we can write SP8 minus 18, which is equal to 2 times A, that is mod of minus 10, which is equal to 2A, or 2A is equal to 10. So A is equal to 5. So the value of A is equal to 5. And also we know that SS dash means the distance between the two foci is AE, 2AE. So we can write S into SS dash distance is here 14 units and here 12 units. So 14 plus 12, 26 units, which is equal to 2AE. So we can write AE is equal to 13. So then we know the relation E square is equal to 1 plus B square upon A square. Or also we can write A square E square is equal to A square plus B square. So A square E square is equal to, that is 13 square. We can write 13 square is equal to A square value is 5 square 25 plus B square, that is 169 minus 25, which is equal to B square. So B square is equal to 144. And length of lattice rectum, we can write 2B square upon A, which is equal to 2 times of B square value is 144 divided by A value is 5. So we can write 288 divided by 5. So length of lattice rectum value is 288 by 5, which is option C. Given a parabola y is equal to x square plus px minus 3, meet the coordinate axis at the points P, Q and R. And if the circle C with a center at minus 1 comma minus 1 passes through the points PQR, then the area of the triangle PQR. So we need to find the area of triangle. we need to find this area of triangle PQR. Now, since the parabola is passing through the point Q1, that is on y-axis, where x coordinate is 0. So if I put x is equal to 0 in the parabolic equation, y is equal to x square plus px minus 3. So we get y is equal to 0 square plus p into 0 minus 3. So y is equal to minus 3. So we got the point minus 3, 0 comma minus 3. So point Q is 0 comma minus 3. And the center of the circle, let us consider this is C, is minus 1 comma minus 1. So that we can find the radius of the circle. Radius of circle C is equal to, we can find the distance between the Q and C, that is 0 minus of minus 1 whole square plus minus 3 minus of minus 1 whole square, which is equal to under root of 0 plus 1 square is 1, and again minus 3 plus 1 is minus 2 whole square, which is equal to 1 plus 2 minus 2 whole square is 4, that is root 5. So the radius of the circle is root 5. And now the point P, the equation of the circle, we can write equation of circle x minus of minus 1 whole square plus y minus of minus 1 whole square is equal to r square, that is root 5 whole square. By using the formula x minus h center radius form, x minus h whole square plus y minus k whole square is equal to r square, where h comma k is the center. So simplifying, we'll be getting x plus 1 whole square plus y plus 1 whole square is equal to 5. To get the points P and R, since the points P and R are on x-axis where y is equal to 0, so put y is equal to 0. So we get x plus 1 whole square plus 0 plus 1 whole square is equal to 5. That is x plus 1 whole square plus 1 is equal to 5. On simplifying, we'll get x square, or let us simplify this, x plus 1 whole square is equal to 5 minus 1, that is 4, which is 2 square. So here we can write x plus 1 plus or minus 2 whole square we can write. So x plus 1 is equal to plus 2 plus or minus 2. So x plus 1 is equal to 2, or x plus 1 is equal to minus 2. So x is equal to 1 or x is equal to minus 3. So we can conclude the point P as, point P can be taken as where y is equal to 0, x is equal to minus 3 comma 0, and R is the point, we can say 1 comma 0, and Q is the point 0 comma minus 3. Now area of the triangle, PQR. So we have the formula half mod of x1 of y2 minus y3 plus x2 of y3 minus y1 plus x3 of y1 minus y2. So here we can consider x1 y1, x2 y2 and x3 y3. So here we can write, which is equal to 1 by 2 mod x1 is negative 3 of y2 minus y3, that is minus 3 minus 0, and again plus x2 times, that is 0 times anything is 0, so that is y3 minus y1, so we can add 0, and again plus x3 times, that is 1 times of y1 minus y2, so it's 0 minus of minus 3, that is 3, so which is equal to 1 by 2 times, so minus 9 plus 3, sorry, plus 9 plus 3, which is equal to 12 upon 2, which is 6. So area of triangle is 6 square units. So 6 is the answer, which is our option 1.